Okay, it's running. Hi there. I wanted to share some code that I wrote. I have been kind of trying to learn how to code for about a week now, and I figured that kind of running through something that I'd written on a video might help me to kind of um, I don't know if understand my own process is the best way to put it, but you know, so you write something and you know in real time kind of what the thing that you're trying to do in the moment is, and then you get done with it and it works, but you can't kind of it's hard to have like a high level concept of everything you've done. Um, I'm hoping that making a video um, will help my mind to kind of like get a grasp on what this whole thing does. So this particular program is one that takes an integer and turns it into uh, turns a decimal integer or a base 10 integer that is into binary. So you see I entered 14 and I got 1110. So if we count this up, there's a 0 in the ones place. 2 plus 4 is 6 plus 8 is 14. So the first line of code, I'm just gonna kind of go like line by line. It's 48 lines of code. I'm sure I could have done it more efficiently. I haven't gone through and kind of like Googled ways to do this, just because I wanted to stay in a place of working from my own thought process as opposed to learning from. I did actually Google to learn how to kind of um, how to do some tactical things like this. This list insert is something that I learned as I went. But as far as the overarching strategy, I tried to come up with that on my own, and it's not. It's a pretty simple process. So first thing you do is you enter an integer. So you initialize this variable and you say this number is equal to this basically tells the program that it's going to be an integer. Um, this tells the program, okay, we're going to have some user input, and then this is the output before the user input comes in. So again, I'll press this run button, and you see that the text in the innermost parentheses is displayed here, and then I can now input a number, say 79, and then it runs the program and spits out the binary. And if you want to check that at home, you can. I've done enough checking that I'm confident that it's right. But let's just see. Okay, 1 plus 2 is 3, plus 4 is 7, plus 8 is 15, and then that's going to be plus 64. So 64 plus 15 would be 79. Okay, so that worked out. Okay, so we see this line just says, hey, enter a number, and you enter a number. And then this first little condition that I set here is just to check if the number is zero. Because what I noticed after I'd written all of this is that it worked for all non-zero positive integers. But if I entered in zero, it would spit back an error. And I don't remember exactly why I didn't like it. It might become obvious as we go through here. Um, but so what I said is, look, if the number, if num, remember that's the variable that is equal to the user input, if that is equal to zero, then just spit that number back out, print num, and then exit. That you're done. You don't have to do anything else. If I input zero here, um, then and I hit enter, then it just says, okay, well, 0 is 0. 0 is 0 in base 10. 0 is 0 in base 2. So, so that this first thing just kind of takes care of that one off. And the reason I put it at the beginning again is so that you don't run into an error. The error occurs somewhere around here. So if it's a 0, the program prints out 0, and then it just shuts everything down. And I might go back and kind of rearrange this so that maybe I'll make it so that you can enter. You don't have to press this run button every time you enter an integer. Maybe I'll make it so that you can convert as many numbers as you want to binary, as many decimal numbers as you want to binary, and then you press Q or something, and then it's done. But in the meantime, I'm just going to keep this as it is, and you enter in one number, you get out your binary, and then if you wanna do it again, then you press the play button again, or the run button again. All right, so that takes care of 0. For everything else, so the essential kind of the high level overview of what's going on here is, so the program is gonna, let's say that our number is 34. Okay, essentially what this program does is it starts off and it tests, it starts off testing 2 to the power of 0, and it says, okay, is this number, can 2 to the 0 divide into this number? Okay, yes. Well, can 2 to the first power divide into this number? Does 2 divide into 34? Okay, yes. And it keeps doing that until it gets a number that does not divide into it. And I don't mean does not evenly divide into it. I mean that if you divide 2 to some power into our number, you're going to get back a result that's less than 1. So for example, okay, so I pick the number 34, and then the program starts, okay, does 2 to the 0 go into it? Yes. Does 2 to the 1 go into it? Yes. Well, when it gets to 2 to the 5th, which is 32, that'll still go into 34 at least one time. But then when it gets up to 64, right, to the 6th, it will return a value less than 1, because 64 is less than 34. So if you do 34 divided by 64, you're going to get back a number that's less than 1. And so this program says, great, that's our highest, our most significant bit. That is, it goes, okay, so 64 doesn't go into 34, so we're going to go back to 32, and that's going to be our most significant bit. And then so while it's checking all of those powers of 2, right? 2 to the 0, yes, okay. 2 to the 1, yes, okay. 2 squared, yes, okay. It's keeping track of how many places. It's basically like putting down a 0 so that when it puts down the 1, it's going to have the right place value, because the place value is very important in binary. A 1 can mean, it can mean 4, it can mean 64, it can mean 256. So it's the number of places after the 1, the first 1 that we get, determines the value of that 1. So and then we are going to utilize our knowledge of how many places there are to kind of work backwards from there to fill in the gaps. So we're going to identify the most significant bit, and then we're going to kind of work backwards from there to fill in the rest of the digits. Okay, so just these first kind of initializations. So list is going to be, I named this list, and I'm not sure. I probably better to use a list than a tuple, because you can't change tuples. I don't, these are structures that I've just structures might not be the best word, but I've been I've been learning Python again for about a week, so I essentially just kind of learned how to use lists, really kind of today. So I found that um, a list would be good for kind of keeping track of my bits, my digits. So I initialize this list and I don't put anything in it. All right, this exp is for exponent. So I'm initializing it at 0 because the first value that we're going to check for is 2 to the 0. So this exponent is that 0 in 2 to the 0, and then we'll increment it upwards to check larger and larger powers of 2. Okay, so this value check is our number that we've entered divided by to some power, right? So this double this double asterisk raises this number to a power. If it were just one asterisk, it would multiply. Because it's two asterisks, it raises it to a power. So essentially what this does is it divides the number that we've entered by 2 to some power, and then returns the value. Basically it defines check as that value, as the number divided by 2 to some exponent. And we'll use that again to check whether we're going to keep going, whether we're going to keep incrementing this exponent and checking larger and larger numbers, or whether we're going to stop and kind of slap down a 1 and then work backwards to fill in everything else. And we'll get into how that's done down here. And then this place, this I don't want to get too far into here, but I initialize this place as 1. Essentially, this is going to help us once we start working. Once we identify our most significant bit and we start working backwards, this place variable is going to help us to basically stay on the right elements in our list. If you have a list, and let's say I have like 3 elements in this list here, the index of each of these from left to right is going to be 0, 1, 2. So that's kind of the place. So this, when I say place equals 1, we're going to use that to say that we want to start at this place in our list, because we will have already identified our most significant bit, and then it's going to start with 1, and then I'll show you later how we deal with that, or what we do with that, I should say. So let me go back to to not having anything initialized in this list. So the first kind of functional block, other than this one-off where we check to see if the number that we entered was 0, this first block is a while loop. And so we say, okay, while this check here is greater than 1, we're going to increment the exponent. And actually what we could do, I'm not going to change it, but I learned, I could have written this as exp plus equals 1. So that's kind of like a slightly more compact way of writing this. I'm not gonna change it now, just because I want to not needlessly make the task of explaining this more complex. But that's a cool thing that that you can do to make your code a little bit more compact, especially because these increment operations are pretty common. You can also do it with a decrement operation. So like if I wanted to say that exponent is equal to exponent minus 1, I could say exp minus equals 0, and it would decrement that variable. Okay, so All right, so we've said while check is greater than 1, we're going to increment the value for exponent, and then we're going to redefine the check variable as the number divided by 2 to the exponent value, right? And so what that's doing is it's saying, okay, so while, let's just take this line by line. So while check is greater than 1, well, remember that if our number is, say, 65, um, we want to keep doing this while loop as long as uh, the as long as long as the number is bigger. Sorry, as long as the number is bigger than 2 to some power, right? So if it's 65, we're going to keep on going until 2 to the exponent is 128. Um, if we choose 65 for our number, I'll just enter it in here. Um, yeah, that's another thing that's kind of annoying about this trinket. This online kind of like editor and compiler is pretty handy. But when you press run, you also have to click over here to the compiler, or else it'll enter what your input into the editor, and that's just a minor annoyance. But all right, so 65, I enter that in, and you see that this one is in the place for 64. So that's 2 to the this place represents 2 to the sixth power, which is 64. So um, so this check is basically going to run as long as the 2 to some number is less than 65, right? Because it's going to be 65 divided by 1, 65 divided by 2, 65 divided by 4. And 65 divided by 64 is fine. That 65 divided by 64 still gives us a quotient of greater than 1. But then on the next go around on 128, um, that's going to give us a value of less than 1. And so we want to stop, because we don't want to put a 1 one spot to the left of here, or else it would represent an incorrect value. Because the way that this works is that you have 64. This bit represents 64. This bit represents 1, and 64 plus 1 is 65. Well, if I had 128, that's I can't do anything with that, because I can only add on to the value. I can't subtract from it when I'm representing a base 10 value in binary. Okay, so we say while our number essentially is greater than the number that we're dividing it by, right? Just it says like keep adding 1 to the exponent. So it's like you start with 2 to the 0, and it's like, okay, does 2 to the 0 divide into our number? Yes. Okay, well, add 1 to the exponent. So now it's 2 to the 1, which is 2. Then you go 2 squared, which is 4. Then 2 cubed, which is 8. Then 2 to the 4th, which is 16. And you keep adding 1 to that exponent and dividing 2 to that exponent into the initial number to get the check value. And as long as that check value is greater than 1, you keep doing that. Now, each time you do that, what I'm doing is I'm adding a 0. List dot insert. Okay, so you have list dot append, which I'm not using in list dot insert. And so what list insert, what this says is, okay, so like if our list is between these brackets here, remember that if I have like values 9, 5, and 4, this is index 1, this is index 0, this is index 1, this is index 2. So these two values inside the parentheses, the first one is the index, and the second one is the value that I want to put in that index. So each time this while loop iterates, it says, okay, I'm going to put a 0 value in the 0th index for this list. So basically, when you do, so basically it's so essentially what this does is it starts off and it goes through, it checks for the exponent 2 to the 0. Um, um, Wait, is this gonna work for 1? Let's see. It spits back 1. Why does that happen? Because I initialize the exponent as 0. Oh, I think, okay, so I think it'll work out, but so we start off, basically I start off checking for 2. Um, why did I do that and why does it work? It works, but okay, so anyways, I'm just going to keep talking about list.insert and we'll get, so this is a mark of a beginner, is like I feel like I've done something wrong, but it works. Anyways, okay, so this insert, we start off, there's nothing in here, right? And then it's going to try this check, and as long as check is greater than 1, it's going to keep popping a 0 in that first spot. So it's going to pop a 0 here, it's going to add 1 to the exponent, so now it's going to try the check for 2 squared. All right, if that works, it's going to pop a 0 in the first spot, right in the 0th index, and it's gonna, if the check is still greater than 1, then it's gonna pop another 0 in there, and it's just gonna create like however many numbers of places, that it can. So let's imagine that our number is, I'm going to do 4 just because this will work nicely. For 4 is an even power of 2, and so we'll see what happens. All right, so we start off with nothing, right? So this goes from the exponent equaling 0 to the exponent equaling 1. It redefines check. So check is now our number, which is 4 divided by 2 to the first power, right? 4 divided by 2 is 2. Let's just keep that in mind. So it comes down here, and it inserts a 0. All right. So it checks the while loop again, and it said, or the condition, I should say, and it says, okay, is check greater than 1? Well, we said check was equal to 4 divided by 2 to the first power, which is 2, which is greater than 1. So it says, okay, great, we're going to do it again. So we're going to add 1 to the exponent, so our exponent is now 2. It's going to redefine check as number, right, 4 divided by 2 squared. So 4 divided by 2 squared is 4 divided by 4 is 1. And then it's going to insert another 0 in here, right? So it's going to insert a 0 in the 0th index spot, and then it's going to come back and it's going to say, hey, is check greater than 1? Well, no, check is not greater than 1. Check is equal to 1, right? Because our number is 4, this was 2 squared, so it was 4 divided by 4, so check was equal to 1. So now this sucker, our list is looking like that, okay? And it's going to pop out of this while loop and go to the next line of code, which checks for if check is equal to 1. Incidentally, this double equals is literally a check. If you want to set something equal to something else, you use 1 equal. If you want to check if this variable is equal to this, integer, or you can use it with Boolean values. You can even use it with a string, I think. If you want to do a check, then you use double equals. And you can also, you can check if something is greater or equal to. You can check if something is not equal to something else. Using it would look like this. Just real quickly, that would be not equal to. Anyways, so all right. So remember check was equal to 1. So this asks if check is equal to 1, and yes, check is equal to 1, then we're going to insert 1 in the 0th spot. So remember, insert adds an element to our list. So it's going to go, okay, boom, and now this actually will this is, 1 0 0 is 4. So I'm gonna go ahead and just comment this out, and I'll put in 4 and get 1 0 0. So yeah, so you see there's all this other code, and I could have done something to skip, just to basically say, okay, we're done, but I didn't, because, so, it says if this is true, do this, and then it's going to go, to the end of this else statement, which you can see, like, this else statement lasts all the way down here to the end of the program. This is the last line of the program. So once we insert this 1 into the list, and in the case of 4, we get, a list with the elements 1, 0, and 0 in that exact order, then it prints it. And I'll get to this. This is not your run-of-the-mill print statement. Essentially, what all this stuff does is it tells Python to get rid of the brackets and the commas, which is, was kind of a pain in the butt to find on, I think I found it on, on a Stack Overflow forum. But I'll get into, I don't understand it that, it's not too confusing when you look at it, but let's look at it once we've understood the rest of the code, because it's really not about finding the values, it's just kind of about cleaning up the presentation. So you can see, so basically that's all that, if the number that we enter is any power of 2, exactly, then this is the only code that really, this and the print statement is all that really matters. So, if I put in 256, I'll get, I'm gonna, so we can go through this, and that's 1, right? That would be 2, that would be 4, that would be 8, that would be 16, 32, 64, 128, and you can see that 256 is indeed in the correct place there. And all that we need is this code, and we need this code. And honestly, we don't need this, because this is just the check for if the number is 0. Okay, so let's say that we have a number that is not 0 and that is not a power of 2. Did I say a multiple of 2 before? I meant a power of 2. I might have said multiple of 2. Multiples of 2 will actually utilize, unless, a power of 2 is also a multiple of 2, but a multiple of 2 is not necessarily a power of 2, right? 2 times 3 is not a power of 2. So anyways, I apologize if I misspoke. If I didn't, I apologize for clarifying needlessly. Moving on. Right, so if we get back, if at this point we have anything other than a power of 2, we're going to utilize the rest of this code. So let's now say that that our number was 6, right? So I'm going to put in a 6 here, and we're going to see what that looks like, right? We have nothing in the 1 spot, we have 1 in the 2 spot, and 1 in the 4 spot. 4 plus 2 equals 6. Okay, so think about what happens during this while loop. Essentially, what's going to happen is it's going to increment this exponent until 2 to the exponent value becomes equal to 8, at which point check would be not greater than 1 but less than 1, right? Because 6 divided by 8 is less than 1. So it would also, we'd have, if we put in 6, it would, for the first iteration, when the exponent was equal to 1, it would put in a 0. when the exponent was equal to 2, it would put in a 0. And during that, that second iteration, or I'm sorry, the third, so first it says exponent is equal to 1, 6 divided by 2 is greater than 1, and during that iteration we put in the first 0. Then it says, okay, oh, I see okay, I think I know. Yeah, okay. So, okay, sorry. All right, yeah, so the first iteration, exponent's equal to 1, 6 divided by 2 is greater than 1, and the 0 gets put in. Second time around, exponent is equal to, so yeah, so that's what happens. So the exponent starts off at 0, and this check, that's funny, I didn't initialize this check value, but it still works. Oh, because it defines it here. Okay, so that's interesting because I can't, it's interesting that it lets me do that. I would think that it would get here and it would, oh, because I defined it here. Okay, I did, okay. So this first go through, oh, I see. All right. You guys listening to this earlier were probably thinking I'm an idiot. So the first go through, the check is defined as the number divided by 2 to the 0, which is the number divided by 1. Okay, so I apologize for misspeaking earlier. Okay, let's try that again. Okay, so our check is defined, right? So we've put in 6, and our check is 6 divided by 1, which is 6, which is greater than 1. So we get to here, we say, is check greater than 1? And it says, yep. So then we add 1 to the exponent, so the exponent is now 1 instead of 0. We redefine the check so that the check is now 6 divided by 2 to the first, 2 to the 1, which is 6 divided by 2, which is 3, right? So check is now equal to 3, and we have our first 0 put in. Okay, so now check is equal to 3, which is greater than 1. It increments the exponent again. So now exponent is equal to 2. So now 2 squared is equal to 4. And this is 6. Check is equal to 6 divided by 4, which is 1.5, which is still greater than 1. And then it adds this second 0. And then it comes back, it checks, it says, is check greater than 1? Well, yeah, it is, because check is 1.5, which is greater than 1. It adds 1 to the exponent. So now we're dealing with 2 to the third power. So now check is 6 divided by 8, right? And it's still going to do this. It's still going to add one more 0. But now, when it goes for the next loop, when it goes to the next loop, the check will not let us back into the loop because check is going to be less than 1. It's going to be 6 divided by 8, which is I think 3/4, or is it 2/3? Yeah, it's 3/4. So it's gonna spit out of the while loop. So now we have these 3 zeros in the list. Okay, it goes to if check is equal to 1. Well, no, check is not equal to 1. Check is less than 1. So it goes to this else statement. So this else is basically, I could have done an elif statement. I could have, said elif, which is basically, it basically says otherwise if this condition is met, but we don't even have to list the condition because check is either greater than 1, it is equal to 1, or it is less than 1. And so everything else is going to be a less than 1. Okay, so now we have this, and we're in this block. So now what we've got here, the very first thing that happens, what this does is it takes the 0th element of the list, which is this first one here. all right, and it sets it equal to 1. Okay, so it takes this 0 and it sets it equal to 1. All right, so now we have basically this, if we printed this out, it would be equal to 4. All right, so now instead of, before we were incrementing the exponent, we were adding 1 to it. Now it's going to work its way back down, right? It found like this biggest, this biggest bit. This bit that's equal to 4 is going to be the largest bit, right? If we did one more, it would be equal to 8, and that would be greater than 6, and that would not work. So we found this biggest bit, and now we're going to work back down to these, which, this represents 2 squared, this represents 2 to the first, this represents 2 to the 0. So our exponent is actually sitting at a value of 3, right? Because that 2 to the 3 value, which was 8, is the thing that made this check value less than 1. So we don't want the exponent to be equal to 3 because that doesn't do us any good, because the value of 6 does not contain, doesn't contain a value of 8 anywhere, or else we'd have to subtract from it. Okay, so we're down here. All right, we've already done this. We replaced this 0th element from a 0 to 1. And now we're taking off, we're going to start to decrement the exponent value. So the exponent value was 3, now it's going to be 2. And I made this value out, which I hadn't done up here. So out is equal to 2 to the exponent. So that means that, remember, our exponent, we subtracted 1 from the exponent, so now the exponent is 2. So now the value of out would be 4. And what we're going to do with this is we're going to subtract it from our original number, right? Because we've already placed this one in this place, right? So this is equal to 4. Our original number is 6. So what's left over? 6 minus 4 is equal to 2. So we have to find a way to represent the remaining value of 2. So I say, okay, so a new number is number, right, is the old number minus this out value. So when I say out, I mean that the amount that we have to take out of the number so that we know what else we need to represent. All right. So then this this number value becomes 2, right? 6 minus 4 is equal to 2. And then this times value I set equal to the exponent. And I don't know if I needed to do that, but it made it easier for me to think of, because so times is gonna, like up here we used a while loop, right? Because I don't know how many times I'm gonna have to add 1 to the exponent before I get my most significant bit. But now that I have all these places, I know, if this is a machine, and or let's say that we make another iterative loop of some sort, or iterative process where we're going to be moving from here to the right. So we start here, and then we move here, and then we move here. I know exactly how many times I'm going to do that. I'm going to do it 1, 2 times, right? If I had established that that our most significant bit was over here in the spot that represents an amount of 8, then we would go 1, 2, 3 spots over to the right. So at this point in the code, we're able to determine the number of iterations that we need to check whether we're going to essentially change these bits from 0, the zeros that we established up here, that we inserted here, if we're going to change those bits to 1s. We basically know how many zeros at this point we need to deal with. So what I do is I that this times kind of represents the number of times that we're going to have to move over to the right, and we had an exponent that was 1 greater than we actually needed in order to, you know, we had an exponent value of 3, right? Our number was 6. Okay, our number was 6, and we incremented our exponent value up to 3. 2 to the third is 8. So we decremented that value down so that the exponent value moved from 3 to 2. And then we set this times value equal to our exponent value, which is 2. So we're going to move 1, 2 times over to check these to see if we need to change them, their values from 0 to 1. Okay, so still within this else, I do a for. I think for loop is the correct way to say it. It's there are a number of ways to deal with for loops in Python, and I kind of looked this one up. So this is for x in x range times. So essentially what this is saying is we're going to do this, we're going to loop through this many times. Remember, times is equal to 2, which was equal to exponent. So basically it says, okay, we're going to do something 2 times. So I think I could have named this anything else. Let me just try. Like let's instead of saying X, let's say John. So that might not work actually. For John in John range. No, I don't think it's gonna like that. And I think if I wait, okay, let me yeah, I don't even want to mess with that because what happens sometimes is like if I get an error, like it'll make this line red, and then sometimes even if I fix it, the red line will stay there, and it's just a bug with Trinket. But I don't want to mess it. I don't want to anger it right now by doing that. So I think this needs to be an X, and this needs to be X range. So basically, like, yeah, in the range of this many times. So again, I'm sorry I can't really explain the mechanics of what this means precisely, but for this syntax, it's going to run through a for loop that many times, right? Or it actually might go, was it going to go 3 times? Because 0, 1, no, I think it'll go through twice. All right, anyways, without further ado, let's say it's going to go through 2 times, right? Because at this point, we know that we have a value of 4 here, and I'm going to have to move over and check this, 1, and I'm going to have to move over and check this, 2. So, okay, so we're going to do this 2 times, right? So first, we're going to decrement the exponent again. So the exponent goes from 2 to 1. And now we're dealing with 2 to the first power, which is 2, which is this place, all right? So now we redefine out again as out equals 2 to exponent. This is essentially the same thing, except because exponent changed, it's not going to just update that. I have to kind of I think I have to yeah, I mean, if I comment this out, is it going to work? No, it's not. Okay, so this is necessary. So you have to redefine out with the new exponent. So the out value is now 2 to the 1, right? Whereas up here, it was 2 squared. So now the out value is 2 instead of up here where it was 4. Okay, so I'm going to do it. I'm going to run a check again. So check is equal to number divided by out, which is essentially what we did here, except I have a variable for 2 to an exponent, right? I just was able to rename it. So we run the check to see if the number divided by the out value is well, let's see. I mean, so we have this time. It's not a while loop. We check. We say, okay, is check. Is number divided by out equal to 1? Is it greater than 1? Or else, the only other thing is it's less than 1. So if it's equal to 1, what we do is we replace. Now here's where that place variable comes up. Remember, up here I had set this equal to 1. And remember, and so what we're using this for, so this says list place, list bracket place, close bracket equals 1. So what this does is this passes that value of 1 into here. Okay, and 1, when we're talking about the index of a list of elements, this is 0, this is 1. So it starts with that second value from the left, right? Remember, our first value already has a 1, no matter what. Unless we put in a 0, our biggest value is already, our 0th list element is going to be a 1. So I want to start on the 1 element, which is the second value. I know it's kind of confusing. So if the check is exactly equal to 1, right, meaning that when I divided my number, remember that's my new number, right? So here, our original number was 6, all right, and then we figured that the most significant bit was 4. It's 1 in the third place, so it's a 4, and then we took that out. So we said 6 minus 4 here is equal to 2, right? So that's what we got to deal with left, is that 2. So now num here is equal to 2. And then we took off 2 exponents from 2 to the third to get 2 to the first. And then we said, okay, number, which is, remember this new number is 2, divided by out, which is 2 to the 1, so it's 2. So 2 divided by 2 is equal to check, right? So 2 divided by 2 is equal to 1. So check is equal to 1. So this next line says if check is equal to 1, which it is, we're going to replace the element in the first position. So really the second position, right? Because it's the index value of number 1. We're going to replace that with a 1. So now this 0 becomes a 1. And we're done. So I put a break here. Maybe I should have put an exit. Oh no, because I put a break, which just basically kicks this out of the loop. So it's going to go down to the print statement. And the reason is that anytime if that check value is equal to 1, that's going to be the last bit. Because if the number is exactly equal to 2 to some exponent, then it's, whatever remaining value we have is going to be perfectly represented by whatever value of 2 to some power we're on. So in this case, again, like we're dealing with 6, so you can see here that this that we've just defined this middle. Well, I can't really do it, but okay, I'll go here. We've just defined this middle value as 1, and there's nothing else. Okay, so if let's say that instead of 6, we were dealing with 7. Okay, so now we've still replaced this 0 with a 1, but now check is not equal to 1. Check is still greater than 1, because now number would have been equal to 3 instead of to 2. Because remember, we started out with 7, so this would have been 7 equals 7 minus 4, and 7 minus 4 is 3, right? So that would basically cascade such that check would be equal to 3 here, and 3 divided by 2 is not equal to 1, it's greater than 1. Okay, so now we're still going to do this deal where where we replace the the index value of 1 up here with a 1, right? So remember, the index value of 1 is in this place, right? So this is an index value of 0, this is an index value of 1. So here, this says, okay, we're going to replace that index value of 1 with a 1. So we change this from the 0 to the 1. Okay, but now we're not done. So now I'm going to increment the place value. Okay, so place is now equal to place plus 1. And you can see down here I got hip to that just place plus 1, or I'm sorry, place plus equals 1 deal where I save some space instead of saying place equals to place plus 1. Yeah, during this whole thing I was kind of like Googling stuff and I found that and I said, oh, I'll start doing that right now. Anyways, so now we've incremented that so that place is equal to 2, which will make it so that we're dealing with this last bit here. Okay, so now, okay, we've done that. We've changed the place value to 2, or we've added 1. We've incremented it, so from 1 to 2. And now we're redefining number again, which do we need to do that? Okay, so, well, let's try this. I think we must, yeah, okay, so did we redefine out though? We redefined out here. Okay, so, right. Okay, so out was equal to, oh, my brain is getting scrambled. All right. Okay, so let's remember what happened. It went all the way up to, so we're dealing with 7 now, right? Our number is 7 instead of 6. But, so if we go back and think about everything that happened, during this while loop, the exponent got all the way up to 3, which means this value for 2 to the exponent got all the way up to 8, and then we took it down, right? And then we took it down again. So our exponent got all the way down from 2 to the third to 2 to the first. And then here we're going to redefine number. So number, whereas before it was 2, when we were dealing with the number 6, now it's going to be 3. So it's going to be, so the out value as defined here is, so this exponent would be 1, so 2 to the 1 is 2. So now this number, it's number equals 3 minus 2, so number equals 1. Okay, so this is a for loop. So remember, it's going to do this, this times was defined as the exponent. So it's going to do it twice, because at this point, the exponent value was 2, right? It was 3, and then we made it 2, and that's when we defined times. So times was equal to the exponent, which at that point was 2. Then we decremented it again, right? So but that means that we're going to do this we're going to run through this 2 times. Okay, so when we got here, okay, we we still replaced this with a 1, and then we changed this number value from 3 to 3 minus 2, which is 1, and then we're going to go back and do, because we said we were going to do the for loop 2 times, so we're going to do this again. So we're decrementing the exponent value one more time, so instead of being 1, the exponent value is 0. All right, so now the out value is 2 to the 0, which is 1. And so now our check value is our number, right, which we just redefined as 1, right? It was 3 minus 2, which is 1. And the out value, which is 2 to the 0, which is 1. Okay? So now check is equal to 1, and that brings it here. Okay? So again, it's going to change whatever the value of place is. And remember here, we incremented the value of place so that instead of being 1, how we initialized it, it's now 2, which is here, right? Because it's 0, 1, 2. Okay, so now we're going to set that equal to 1. And we're pretty much done. Now we have the correct values. And all we need to do is get rid of our brackets and our commas. And that's what, oh boy. You know what, I have to go to the bathroom, so I'm going to pause this and I'll be right back. Okay, I'm back. Sorry about that. Okay, so now for this value of 7, we have, everything is in place. We have all of our bits, right? This is 1 plus 2, which is 3, plus 4, which is 7, which is 7. So we're done, and we ended on this if check equals 1 part of the code, which breaks us out of the loop and takes us straight to this. I'm sorry if you can't see this very well. This print statement, which essentially what it does is it takes the list and it makes it a string, and it concatenates all of the elements of the list as strings. So, and again, I just kind of found this on Google, or on Stack Overflow via Google, but it works. I was having a really hard time. This had been showing up kind of as in a list form, which includes square brackets at either end and commas in the middle, which is not how you want to really display binary. Okay, but there's one part of the code that we haven't dealt with yet, though, and that's this else. So we dealt with, we looked at what if our number was 6 and what if our number was 7. Well, what if our number was 5? Okay, so I'm just gonna go ahead and we're gonna see what it needs to be. Okay. So 5 is 101, right? So we can see that's correct. 1 plus 0 plus 4, 1 plus 4 is 5. And so let's go back to the point where we've gone through this while loop, and that's put this 1 in the place that represents a 4. And this exponent is 3, and everything magical happens so that we're in this for loop and we're going through everything. And what happens is our number goes from I believe here our number goes from, our initial number is 5. The out value is going to be 4. So 5 minus 4 is going to be 1. Okay. So now we come in here, and our exponent was 3, then it was 2, right? Now it's 1. So our out value is 2 to the 1, which is 2. And our check, remember our new number is 1, right? Because it was 5 minus 4. So this is 1 divided by 2. Okay? And so now it says, okay, so 1 divided by 2 is 0.5, which is less than 1. So, right, so it goes, okay, is your number equal to 1? No. Is your number greater than 1? No. Right? 0.5 is less than 1. So that is handled by the else part of, I can't think of the right technical word, part of the deal. So we're in this else condition. And it says, okay, well, if the check is less than 1, then that means that you don't have, remember, we're checking for this place, and this place is equal to 2, right? And we already have a 4 here, and our number is 5. So if I said 4, if I put a 1 here, that would be 4 plus 2, we already know that equals to 6. And we just know that equals to 6. But we don't want that because we want 5 and we want this to be a 0. So what this else does is it says, okay, well, you don't have enough juice left to to handle that 2 place. You only got 1 left. All right. Well, so now we're going to. I don't even have to do this really. I don't think this is necessary. So I'm going to comment that out. I'm gonna say 5. It's funny. I was having some problems earlier with like 50 was a problem. Let's see if that's right. So that's 2, right? Plus 16. So that's 18 plus 32. 18 plus 32 is indeed 50. All right. So I don't think I need this. This is already equal to 0. So if we want this number to be equal to 0, we don't have to set it equal to 0 like I was doing here. We just have to leave it alone and then increment the place so that, now we'd be dealing with that. So I'm commenting this out. In fact, I'm just going to delete that so that, I can say that my program is 1 fewer lines of code. I'm going to delete that. Let's see how many. And, I could probably make this, more compact at the sacrifice of readability. So I'll tuck that in a little bit. So we got like 45 lines. Kind of seems like a lot to be doing what, as simple a program as we're doing. I might later on, and I'm sure I could have utilized functions. There are a lot of things, like I'm brand new to coding. So, I'm sure there are a lot of tricks of the trade that I'm not really hip to. And some of those are, I'm sure, general coding things. Some of them are Python specific things. But I don't feel too bad about this. I think it's a neat little machine. I also made one that a program that factors prime numbers, and maybe I'll make a video that takes us through that. I think it does help to kind of go through this line by line and explain it. And it's been over an hour. Here, I'll drag you can probably see if, I don't know if I'm gonna put this on YouTube or what, but you'd be able to see the time. But here you can see it now too. It's a long time to talk about 45 fairly simple lines of code, but it was helpful for me. And if you listen to it, I hope it was either helpful for you or you just like the sound of my voice, because we all want to get things out of stuff. And if you've listened to this for an hour, I hope that it hasn't made your life worse. Okay, so I want to summarize anything here. I'm gonna keep going with this. The idea is to upskill, right? So I don't know how to program. I took a symbolic logic class back at community college, and I did pretty well in it, and I enjoyed it. And I figured that coding is similar to symbolic logic, so maybe I'd be decent at it, or at least have some aptitude for it. So I'm giving it a shot, and I don't expect to be like job ready anytime soon. I think it would be very quick to go from essentially nothing to job ready in like half a year. So that's not the goal. Is to kind of keep this as a hobby, and then hopefully be ready for like some sort of like, at least to take on kind of projects that you could find on like Fiverr or something like that within maybe half a year, and then maybe half a year after that to be ready for some sort of entry level position. I do work in kind of like I work around kind of computer stuff. I'm not an engineer obviously, and I'm not a coder, but a lot of my job involves like dealing with people who code and dealing with descriptions of things that can involve code. So that should help too. Anyways, yeah. So this, it's funny that I think for this program, if you were to turn it around and go the other way to convert binary into decimal or into base 10. I don't like to say decimal because we think of decimal as like something with a decimal point that is not an integer value. So when I've been saying decimal, what I mean is base 10 as opposed to like hexadecimal, which would be like base 16. But yeah, so I think it would be require fewer lines of code to go from binary to base 10. And I'm sure, again, like I'm sure there are ways to go from base 10 to binary using fewer lines of code than I did. But again, I'm happy with this. I enjoyed explaining it, and I'm really just searching for an out here, for a way to stop talking, because I've been talking for an hour, and so it's like the wheels just want to keep on turning. So it's an iterative loop of sorts. But yeah, so I'm gonna go take a walk or something, and I hope you have a good rest of your Thursday or whatever day this is that you're watching it. I hope you have a good night if it's night, and I hope things just are good for you, at least intermittently, because things can't be all good all the time. I know. And with that, I'm gonna leave you, and yeah, take care, y'all.